Hey guys, it's Berlin here, and in this video, I'm going to talk about Bytemuck and Borsh. So, Bytemuck and Borsh are two serializers that we typically use in Solana programs. So, Anchor in particularly uses Borsh, and that allows them to use dynamic types like strings and vex straight out of the box. And Steel in particular uses Bytemuck, and that's why typically when we're working with Steel, we have to define those types as bytes. So this video isn't really going to talk about the theoretical parts of both of the serializers, because even me, I need to like go deeper into all that. But what I'm going to do is like show you an example of using these two serializer in a program. So I'm going to be like writing a native program that basically like sets some data, and it's going to have two instructions. The first instruction is going to set the data with Borsh, and the second instruction is going to set the data with Bytemuck. So let's get started. So cd so since it's a native program, it's not like let's say what's it called, Anchor or Steel, where you can just do Anchor init or Steel new. So we have to go the old-fashioned way, cargo. So we're going to do cargo new serializer and do serializer, and okay, we need to make it a leap. So serializer, and yeah, that should be right. Serializer, and yeah, so this should be it. So it just gives us boilerplate. So to get started, let's add the dependencies we'll need. So we're definitely going to need Solana program. So let's add Solana program. And we're also going to need Borsh. The first instruction I'm going to implement in is going to use Borsh. So let's add it first. So cargo add Borsh, and we need to add the derive feature. Yeah. So let's check our cargo.storm. It's set. So let's get started. So typically for native programs, you need to define your entry point. Let's do the imports first. So Solana program, we need to do entry points. Yeah, entry point is first. Then Borsh, we're going to have the serialize. Borsh deserialize. The macros, and Borsh deserialize. Yeah. So now we do entry points. We're going to call the macro. We'll do process instruction. So we've not defined instruction yet, so that's why that shows an error. So now instruction process instruction. So process instruction typically has three params. The first one is going to be the program ID. So that's a pub key, not the type of pub key I wanted. Pub key. And the second param is going to be account. That's basically the accounts we'll pass into this instruction, and that it's going to be a slice of accounts info. And lastly, we're going to need instruction data. So potentially the data we're going to be sending for this instruction, and that should be a slice of U8. Yeah. And this is going to return program results. Yeah. And okay. And why is error? No entry points defined. Why is that? Oh, Z messed up the imports. Oh, comma. Yeah, we should be good. So what next? Yeah, let's define our instruction, which is basically going to contain all the instructions we're going to need. So we do pub enum serializer instruction. And the first variant is going to be the Borsh version we want. So set data Borsh, and it's going to have some params called set. So let's call that set data args. Yeah. And yeah, we're going to use Borsh over at this point. So we could do we need to derive macros. So we just do derive Borsh serialize and Borsh deserialize. And now it's complaining about this. So let's define the structs. So that the args. So the args we're going to need are going to be name, string, dislikes, which is going to be a vec of string, and is goats, which is going to be a boolean. So this is throwing an error because set data args does not use Borsh right now. So to fix that, all we need to do is just add Borsh. So this alone should show us, if you're familiar with my previous videos, while we're working with still uses Bytemuck. When we're defining the instruction data, we can't just like use string or vec because these are dynamic types. We need to use static types like an array to define a string, a vec, and whatever. But Borsh gives us the advantage of like using dynamic types straight out of the box, and it's pretty safe too. So what's next? Okay. So now remember, this program is going to have two different instructions. So we need a way to like match. Basically a way to like, how will I put it? Okay, let this program know which instruction we want to interact with. So typically, if I'm just using Borsh, I'll just do like, let's say serializer instruction try from slice, then I just add instruction data. And if both of the instructions that I was using, like their inputs were supposed to be serialized with Borsh, this would work, because try from slice is like a method from serialized instruction from Borsh basically. But the thing is that our second instruction is not going to be using Borsh, so this won't work. So instead, what we're going to be doing is that we're going to expect that instruction data is going to start with a discriminator. So basically, the first instruction would have 0, the second instruction will have 1, and all that. So over here, we just do discriminator. Yeah, I'm not that great at spelling, and rest. Then over here, instruction data, we do this dot splits first. So this is just going to take the first element of this instruction data. What's the error? Oh, option. So we do okay or else. So we can do something like program error. Invalid account data. Yeah, invalid account data. This note that this is inaccurate. It's possible that, okay, there could be a better what they call it, a better error we could use, but I'm just going to use that. Closure expected to take 0 arguments, but it takes at least 1. Oh, my bad. Oh, and this works. I'm surprised. So over here we just do match discriminator, and if it's 0, we're going to say if it's 0, we're going to be using process set data. Should I call it Borsh? Let's call it process Borsh sets data. So this isn't defined yet, so we have to define it under. Honestly, maybe I should have even defined it before I added it there. So this is basically going to be function set Borsh deserializer. Just like process instruction is going to take the program ID. Pop key is going to take accounts. And in this case, since we already have the types in like string and all that, we could just add them directly instead of like having it as what's it called, having it as bytes. So yeah, we could just say name string dislikes, and that's going to be a vec of string and is goat. That's going to be a boolean, and it's going to return a program results, and yes, it's returned. Okay, fair. Now over at this point we can say, okay, now that we know that, okay, this instruction, at this point we get we take out the discriminator, and okay, at this point we know that discriminator is 0. That means it's definitely the Borsh version. So that means it's safe for us to use the try from slice method on it. So and now I could just say let args equals Borsh, no, not Borsh, serializer instruction try from slice, and we just pass instruction data over here. I'm expecting, okay, what does this return? Oh, results. How about now? Serialize instruction. No, this is wrong. I think it should be set data board. Oh, it should just be set data Borsh. Set data args. I'm sorry. Set data args. And yeah. And why is this panicking? Okay. So basically, here we're just getting our args. So we do let name equals args dot name. Let dislikes equals args dot dislikes. Let is goats equals args dot is goats. And yeah, so now we do process Borsh set data, and we're going to have program ID, which is going to be gotten here, accounts ID, which is going to be gotten here, and name, dislike, and the rest, which is going to be gotten from this point. So now we're getting this error because, okay, we're accounting for a situation where we do get the valid variance, but we also have to account for a situation where we don't get the valid variance. So we do this by using the underscore, and here we just throw an error. So we can just say return error, return program error, invalid account data, invalid instruction data. I might be wrong with these errors. Expected enum results. Am I supposed to do results? Okay. Program error, invalid instruction data. And it works, surprising. So what's this problem? Can't find it. Why can't you? Why is Z changing the imports for some reason? Program results, and yeah. Yeah, and we should be good. Oh yeah, another thing, I made a mistake. So we're not supposed to use instruction data at this point because of, remember, we're splitting the instruction data from discriminator and rest. So this is supposed to be rest. This is what we're concerned with at this point. And yeah, since this returns the results, we need to add this. Yeah. So we're good on that side. So let's start implementing our instruction. So over at program, just like we typically do in still, first off, let's load our accounts. Yeah, so yeah, let's account eta equals account dot eta. Yeah, it should be account dot eta. Am I getting this right? Yeah, it should be account dot eta. So the first account we're going to be using is going to be, it's going to be called goat. And by goat I mean like the greatest of all time. So let's call that goats info. And so next account info, and this should be account eta. And what's the error? I think I'm doing something wrong somewhere. Oh, is it supposed to be? Oh, it's supposed to be a mutable reference. Okay, so the first account we're going to need is the goat account. The second one is going to be a goat PDA info. So next account info and account eta, just like that. And what else are we going to need? The system program, since we're definitely going to be creating a PDA. So this is going to be next account eta. So basically what we've done here is just like load the accounts. Like we've gotten the accounts we're going to need for this instruction. So after that, we have to validate our accounts. Validate accounts. So for the first account, we have to make sure it's a signer. Goat accounts is supposed to be like, okay, the account that calls this instruction. So we can check it's a signer by doing goat info is signer. Let's see what goat info returns. Oh, a result. So I need to add this over here and here and here. So that is signer. So is signer is a field in the accounts info. So basically what we're doing here is just checking that, oh, is the goat info a signer? We could also add is it writable? So goat info is writable, not signer, is writable. So with this, we've done our checks for goat info. Next, we're going to need to do checks on goat PDA. So how we're going to do this is going to be like, we'll need to like derive the, derive the goat PDA address. So it's going to be expected goat PDA, and that's going to be pub key find program address. So so it's going to complain about the seeds. We need to define the seeds we use, so we just say let seeds equals so for the first one we can just make it the first seed goats as bytes, and the second one, let's make it the goats account key, so we can just do key then as ref, and we should be good. So basically we're saying that this is what we should use to define our seeds. Yeah. So now we assert that expected goat PDA should be the same as goat PDA info dot key. Basically, cannot. Oh, this returns tuple, so we just need to get the first one. And what's the issue now? Cannot generate tuple key over key. What? What even is this error? Oh, I'm doing assert when I'm supposed to be doing assert equals. Yeah, my bad. Expected pop key. Okay, we just need to deserialize this and okay. With this, with this we've done okay. We confirm that the GOAT PDA info is like it's actually using the right seeds. So next, let's also assert that it is writable. So it's going to be GOAT PDA info dot is writable. Yeah, and we also need to check that its data is empty because we've not created this yet. So yeah, data is empty. So this method just checks if this data is empty. And yeah, we should be good from this point. Yeah, so let's also place a check on system account. So that's going to be assert equals system program dot key and system program ID. So you're going to make sure that all the right system program is being added. And over here, we just deserialize this. And with that, we should be done with our validation. So at this point, we can go on to our logic. So logic. What do we want to do? So we're creating the GOAT PDA. We need to create the GOAT PDA. Yeah, we need to create the GOAT PDA. And we need to set the data in GOAT PDA. So to do this, we're going to be using invoke. So Solana program invoke, and that's going to take two params, instruction and account info. So I typically like to just call it x. So create I think that should be in system. No, is this Solana program? I guess you're confused. Solana program system instructions create accounts. Yeah, so this should return the instruction of the account we want. So from pub key from pub key is going to be goat info dot key, and top pub key is going to be goat info goat PDA info dot key. And lamp ports, we're going to need to calculate the lamp ports needed for this account, and to do that we need to we need to basically know how much data is going to be in this instruction. So we should be able to get the data by so space is basically going to, let's define space right over here. Space is just going to be should be std meme size of oh yeah, also I have not defined the structure for the what's it called, the data that is going to be inside the, oh lord, why is what it happened again. Why does this keep happening? So basically what's happening is that Z is just messing up my imports, and I really don't know why. This is just annoying at this point. You know what, I'm going to copy it over here, comment it out, so the next time it happens I don't need to like do a rewrite. Yeah, so basically where we stopped is that, okay, we need to like define the structure of the content of the PDA we're creating, so the goats PDA. So that's going to be pub struct goat accounts. We're going to call it a goat account, and it's going to have name, string, dislike, so vec string, and it's going to have is goats and boolean. So I'm going to call this goats account Borsh because this is the Borsh version of it. The Bytemuck version is going to have a different structure. It's going to be represented in bytes directly, basically. So over here we say size of goats account Borsh. Expected value. I think I am doing something wrong. What am I doing wrong? Should be able to do it like this, but I think I'm doing something wrong. Oh, my bad. I'm supposed to use double fishes. Okay, this is not going to be good. Account Borsh. Yeah. So this is one way of doing it. Doing it. Another way would be to do space equal to do this entire thing would be to like, okay, just define the params we're going to need for goats data. So we could just say let's goats data equals goats Borsh, and here will just be name, dislikes, and is goats. So this would be one way of doing it. Then after we do this, we have to like serialize it. So serialized goats data. It's now going to be equals to goats Borsh. So try from no. This is going to be Borsh, then to vec goats goats data, and we're getting an error because unknown goats data. Strange. Goats data. Why does that work when I add? I don't know why that works when I add that. Saying expected. Oh yeah, it does say it expects a reference over there. So after we get, okay, so basically this is like the struct in its regular like form, and what we're doing here is just serializing it. So this is just going to be like raw data, so it's going to be like an array basically. So because of that, we can now simply do space. It's not going to be serialized. Go data dot dot len. No, there's an issue here. Okay, I think this returns the results. So dots len. Yeah, and these two should actually like give us the same. They should be the same thing. but I'm going to go with this second method because we're going to need the this GOAT data later on. So okay, yeah. So we've gotten like the space. Okay, now let's serialize GOAT data length. So we're going to do len equals serialize GOAT data dot len. So basically this is the space. Now to get the lamp ports we need to create this instruction, we do let rent equals rent dot get. Then we do okay, let's call it let lamp ports. So let lamp ports equals rent. That's okay, this returns the result, so add a question mark here, so dot minimum balance, and we add data length. So we're going to add the serialized data length here, and does this return a result? Thankfully it does not. So lamp ports work now because okay, basically we're getting the minimum balance, the lamp ports we're going to need for creating this account, so that's why lamp port works. For space, we just basically copy the length of the serialized GOAT data. So that's going to be serialized GOAT data. Okay, it's expecting U64. Yeah, so for owner, since it's a PDA, it's just going to be the program ID. And yes. And now I realize that this is supposed to be invoke signed, since okay, we're creating a PDA. So the last is going to be signer seeds. Signer seed. So instruction X, we have that settled. Oh, which probably wants a reference. So next is account info. Let's account info equals, so this is going to be the accounts we need in this instruction. Let me check if it's expecting a vec or a slice. I never can remember. Yeah, so it's expecting a slice. So for one, we're going to need GOAT info. So that's GOAT info.clone. I'm definitely going to need the PDA, so that's clone, and we're going to need the system program dot clone. Yeah, so these are the accounts we need for calling this instruction. And next we need signer seeds. Honestly, signer seeds trip me up, so I'm just going to get that instead. The name. Let's look at our previous. So the seeds I used before were just no. So I'm just looking at the seeds I used before. Those goats name. Okay, no need for this. So we also need to include the bump for the signer seeds. And now I realize I did something dumb when I was getting the GOAT data. So let me change this to a tuple. Call this bump. And yep, we should be good. Now what is the error? Dear Lord, save my soul. Wow. Apparently I'm just supposed to do so that fixes it. And why is this error over here? Oh, this is for the space we later did not use. There's an error. Ah, Lord, why does Z keep on doing this to me? Why does Z keep on doing this to me? Why does Z keep on doing this to me? Funny enough, is there another place I can get results info from? Program result from. Program results. Program results. Entry points. You can only find it in the entry points. Okay. Let's progress. When it's time to run it, I'll just go back to that. So with this, we've created, if this chunk of code works, we've done what we said we'll do in the first comment, which is create the goat PDA. So next off, we need to like actually populate data inside the account data. So to do that, first off, we need to check if we need to do a realloc. So basically we're going to do if serialized goat data is greater than goat PDA info dot data, we're going to do goat PDA dot goat PDA info dot realloc, and new length is just going to be the serialized goat data length, and we'll set this to true. What is the issue? What is the issue? Yeah, let's call the method instead. Yeah, so basically what this is doing is that, okay, we're checking that if goat's PDA info currently has the right data length, which it won't. It's probably going to just have wait a minute. Honestly, now that I think about it, we don't need to do this realloc, because at this point we do set the actual length. Well, basically, if in a situation, if it's not the right length, this is basically going to realloc it. You know what? On another later point of this video, let's add a log here to see if it triggers. Now I think about it logically, this isn't supposed to trigger, but let's see if it triggers later on. So with that done, we need to like get goats PDA info. Oh, my bad. We're supposed to call data first, then try borrow mute, then copy try borrow mute. Okay, it returns an error. So and program error. Honestly, I never know the right error to use, but invalid. Let's do invalid account data. No, there should be something else for borrow. Accounts borrow failed. Let me check if there's something for data. Invalid account data. No, let's use the borrow one. So the borrow one is account borrow failed. Then yeah, we should do something like, okay, then copy from slice, and at this point we just are going to pass in the serialized goat data. What's the issue? Okay, so over here we just make it to the slice. So with that, we should be done. We should be done. So as a bonus, I'm going to be using light SVM for testing. So let's just go to the light SVM docs. Under the light, let's go to the light SVM docs. We're going to copy this, and we're also going to add this as a dev dependency. I think I made a mistake with the structure. So inside serializer, okay, let me just do ls so that you guys currently see what we have. So is this even Oh, let me just do ls. So this is our current structure. So now I'm going to create another library, and it's going to be like called program. So that's where we're going to do our that's where we're going to have our program, and we're going to be doing our testing at the roots. So it's going to be cargo new program, cargo new program lead, basically. So over here we're going to copy our what do you call it, we're going to copy our program code, and let's look at the name. We're supposed to, okay, the imports we used previously, so Borsh and Solana program, add them here. What's next? Oh, I think I need to add lib. I need to add lib create pack. What else? I don't see what else. Okay, let's try to compile our program. Okay, also the name, should I just leave it as program? Calling it just program feels off. Let's say serialize our program. So inside program, let's do cargo build SBF. And if there's something wrong, it should tell us. Hopefully Z doesn't add the wrong imports again. Let's go to info. Let's add terminal over here. Results unused on. Okay. Nice catch. So that's on line 113. So over here, this returns the result, and this also returns the result. Should be good. What? Oh, do I still? Oh, I still have it here. Oh, so I wasn't editing the program. My bad. So before I delete it, let me make sure it's in the program. Okay, it's in the program. Over here, since let's just do main. Don't worry about this. This is just like a placeholder. I just need to get program in check. Okay, so 118. Yeah, so basically just add these, and also when we unlock, and we should be good. Okay, we're good on the program side of things. I need to lay back a bit. Yeah, so for lightest VM, first let's add the dependency, but we're not going to be adding the dependency in program. It's going to be in the root crate. So in a way, we're like taking a client approach. Basically, this is our program, and here we're testing it, so treating it sort of like a client. So cargo hard light SVM, we're doing that at the root, not inside program. And while that runs, let's just copy the boilerplate over here. So this isn't just going to work like that. Funny enough, why don't they just add tests? Yeah, and we should be good on that part. So why is this failing? Okay, let me run it. Cargo build. Oh yeah, so I've not added, weird, I've added light SVM, so why is light SVM complaining? Dev dependencies. Just add light SVM, yeah. Dependencies can be a bit chaotic, so I'm just going to find the right versions I used for the test program before I started this recording. So this should be right. So let's go back to our light SVM test. So what this example is doing is just like doing a test of transferring Sol from one address to another, but in our case that's not what we want. Let's do cargo build to see if no matching program. Oh, yeah. This is the issue over here. So they should be serializer program. Underscore. So basically, we're just like importing the program, the serializer program, into our light SVM test so that we can like access some of the types inside our program, types like the serializer instruction. So okay, bring this over here, build again. Oh, yeah. What's next? What's next? Yeah, so we basically need to start testing. We can delete this. We can delete this. Let's comment it out. So let's get our pub key. So this is going to be let's Alessandro. Oh god, I'm sorry, Alexandra. I did say I'm bad at spelling. So if I don't get your name right, I'm very sorry. So let's call this Alexandro Keeper. So for our first instruction in our test, we're going to be using Alexandro. I'm not even sure if I'm pronouncing this name right. Yeah, so Alexandro, light SVM. So we're going to be sending Alexandro pub key. We're going to be sending him about yes, wait, this should be in LAN ports. Need to import. Oh, was it LAN ports? LAN ports. I'm trying to remember the what they call it. I'm trying to remember the type we use for LAN ports. LAN ports Paso native program. That's so weird. Use Solana native token LAN ports Paso. So let's do LAN ports Paso times this. So we're sending this much Sol to Alexandra. Maybe I should reduce this to 10, but honestly at this point never mind. So next we need to get, so remove this. So we need to get our program ID. Let's program ID equals. Now I realize that I did not add a program ID to our program. So we can do that simply by at the top here we just do personal. We're just going to do declare ID and pub key. So give me a minute to just quickly copy pub key. And yeah, we should be good at this point. And that annoying error happens again. Entry point. Honestly, it's possible I would have found a solution off stream. Well, my mind gets more fuzzy when I'm recording. So yeah, we can just say pub key. Is that going to be a string? Okay, pub key, just use the same address, and that should work. And okay, so basically what I'm trying to do at this point is that I'm trying to add a program to our light SVM instance. So to do that, over here we just do light svm.add program, and it needs program ID and bytes. So I'm trying to get the program ID and the bytes. So we've gotten the program ID. Next is to get the bytes. So let's program bytes equals include. I think it's called include bytes. Honestly, I'm just going to copy it. Yeah, include bytes. So to get the bytes, we use this macro called include bytes, and Spanish can be called the name. So this should be serialize the program. Yeah. So this is going to get the bytes for us. So all we're doing at this point basically is just like adding this program to our light SVM instance. So what's next for us is just to call our instruction. Let's have program over on this side so I can keep track of what we need. So just say let's instruction equals instruction, and the program ID is going to be the program ID at the top, and we're going to need accounts, and we're going to need instruction data. Instruction data. Is there a better way of doing this? Yeah, it's going. So this is our instruction. So over here we say let's accounts equals a vec of accounts equals a vec of trying to remember if account is going to be account meta or account info. It's probably going to be account meta. So account meta, that's new. The first is going to be Alexandro.popkey, and we're going to set it to true since it's going to be a signer. And I just realized we also need okay, we need to get the goats PDA. So let me find the seeds over here. So this is the seeds. So this is the seeds. Should we have it over here? Okay. Let's have it over here. Let's see it's equals. So instead of goats info, since we're on the client side, it's going to be Alexandro keypair dot popkey. So from the seeds, we need to get the goats PDA. So let's just call it Alexandro PDA. So Alexandro is our goats, that's why we're calling it Alexandro PDA. So over here we just do popkey, find popkey, seeds, and okay, we also need our program ID. In that case, okay, let's just define it right around here. Expected. Okay, so So this should return a tuple. I doubt we're going to need the bump, but okay, let's just have it as underscore. And yeah, so in the account over here, we're going to call this, oh, I said San, it's Alessandro. Okay, so Alessandro PDA is going to be false. And the last account we need is going to be the system account. New system ID and false. That should be enough. So next we need instruction data. Instruction data. So yeah, we can do let instruction data equals we can call that goats. No. Instruction data, what type does it have here? Instruction data. What's data supposed to be? Give me a minute. Oh, it's supposed to be a vec. Okay, good. So here, let's say let's instruction oh, would I forget how to spell? Let's instruction data equals to vec, and we're going to add 0. So we add this 0 because of 0 is going to be our discriminator, like on the program side, so it's going to let us know that it's going to run the process Borsh sets data. So we need to import, goat accounts, the goat account struct, so that we use serialized program goat account Borsh. So yeah, we say goat account Borsh. Let me say goats data. Yeah, goats data. I'm sweaty. Let's say goats data name. It's going to be string from Alessandro. And dislikes is going to be vec string from bytes, and I know it doesn't like assembly in programs, so dislike is going to be assembly in programs. Private. Okay, it's saying it's private, the fields are private, so over here let me make them public. So yeah, we should be good. And the last field is goat, and yeah, definitely is a goat, and by goat I mean greatest of all time. Next we have to serialize it, so we do goats data serialized equals Bytemuck. No, not, is it Bytemuck? Since we're trying to serialize it, isn't it to vec? Go to vec. Oh, honestly, I've forgotten how to serialize it. There was a point where we did that. Okay, I think the method is Borsh to vec, and we just add goats data. Okay, it's supposed to be a reference. Yeah, so now we just basically, this is okay, goats data in regular struct from form, and over here we just serialize it, so it's in bytes. And now instruction data, we're going to extend it, so we do dot extend, and we're going to add growth serialized data. So we're going to extend it by the serialized. Why isn't this working? This is the version I did earlier. Let's see the difference. So Borsh data extend. Give me a minute to figure out what I'm doing wrong here. Oh yeah, this returns the results. My bad. Okay, so let's just do unwrap. Oh, it's supposed to be data. So just rename instruction data to just data. To just data. And yeah, we have our instruction. We include it here. So we're going to be using Alexandro PDA. No, Alexandro keep here. Yeah, Alexandro keep here. And Alexandra is going to be signing this transaction, so we add this pub key over here. And we should be good. So over at this point, what's wrong with data? Oh, supposed to make this mutable. Okay, mute. Can I just have a reference here? Temporary value. Well. Okay, so let's just add the seeds there to prevent that borrow error. Okay, with this now, let's run our test. I'm not satisfied with how transaction is over here. So let's do match tx res, and if it's okay, if it's okay, what do we do in a okay scenario? Let's say res and we debug res. Okay, I got you. So basically, yeah. So, and if it's a error case, E and debug E. So debug our error. Oh, this is supposed to be res. I'm not using res. And error, debug our error. So this should be E, then meta, then logs. So if it fails, this should help us like view the logs. Okay, let's do that here too. Dot. No, that's not what I want. Logs. Yeah. So I just want us to be able to see the logs when we are running our program. So let me do cargo test. And it fails. Why does it fail? And honestly, why is it in this format? Panicked at line 19. Oh, there are not enough lamp pods to do that transfer. Let's release it to 100. Oh, and everything works, it seems. So now to see our logs properly, let's do cargo test. No capture. Yeah, and it works. We see the logs for the successful case. So in this scenario, we're seeing that what are we seeing? Yeah, so we see how much CUs were spent in like setting this data with Borsh. So it's used like 6,164. So yeah, and yeah, we're done. So it's been about an hour, so I think I'm going to have to stop here, and I'm going to like have a part 2 where I like do the second instruction with Bytemuck. But let's just add this here. Let's say instruction. Let's say Borsh instruction. I would say it was equal to 6 CUs. So yeah, we're going to stop here, and I'm going to continue part 2 another day. Yeah, well, I'm just going to split it. So bye guys, and look forward to part 2.